Well, good afternoon. My name is Nate Schutta. I work for VMware. Best way to describe me is architect as a service. Now that the pandemic is at least waning, or at least they're saying I can fly again, I get to go places again and be in front of folks, so thank you all for hanging out with me. I will admit, the first time someone called me architect as a service, I thought, yeah, that's a pretty good fit. And then I sounded the acronym out in my head and realized they may not have been complimenting me. I'm going to try to take it in the best vein I possibly can. So I've been in this architecture cloud space for quite some time, and of course now my clicker's decided to ignore me. If you're interested in my thoughts on architecture, I wrote this report thing a couple years back, and then of course more interesting probably to what we're talking about today with microservices, I have a companion around my thoughts on how we do this whole microservices thing. But I've lived this cloud thing, my apologies. I always have learned over the last few years people take notes with their cameras. And so I've become more attuned to watching people's cell phones move in that direction. I've been in this cloud space for a while, and you realize fairly quickly that there's a lot of options here. And depending on who you talk to, cloud means microservices, and other people say, no, it's all about modular monoliths, and other folks are saying, I'm just going to put everything in a container and that'll be good enough. And then you got some folks who are like, no, it's all about serverless. Everything is functions. Everything's as a service now, which I think is kind of cool. And then, of course, there's this whole poly-cloud, multi-cloud. We got all these different things. Now, I've done this long enough to remember when it was simpler. It's never been easy, but it was simpler. We had a monolith or two or three, and we released periodically for some value of periodically, and we all worked near each other, maybe within walking distance. But that's not where we live today. There's a pretty good chance today that you've got dozens or hundreds or maybe so many services, you're not even sure how many you have. We've got clients where you ask them that question, they're like, I don't know, we don't bother counting anymore. And when was the last time you did an update? Earlier today. I was talking to one of our clients, and I think I'll show you this slide if memory serves, but they have gotten to the point now where I think they do about 12,000 deploys a month. And you start to kind of roll the math, and you're like, wait, that's like 650 a day, and that's, and I can't remember how many developers they have, so that is spread across multiple developers, but that's a lot. We don't all live in the same area code anymore, do we? We're all over the place, and that's only been exacerbated over the last couple of years as folks have decided, I don't want to live in that particular city center, I'd rather live somewhere else. Now, being an architect has never been an easy job. But now I've got these massively distributed applications, which brings in a whole new level of fun. And I've got teams that are spread all over the place. What do I do about that? Now, I'd love to tell you there's a magic technology you can use or something we can sell you. That's not how it works. There are no such things as magic sparkle ponies. I'm sorry. I know. It would be nice if there were, weren't there? That'd be kind of fun. I'd love to be able to sell you one. I'm not going to lie to you. So how do we avoid the pitfalls of all this? There's real engineering issues here, friends. We also need to be very, very aware of resume-driven design. This happens a lot in our industry. I've done it. I'm proud enough to admit that. We've all had that experience where we need to use this on our project, and if we're really honest with ourselves, the only reason we need to use it on this project is because I really want to put it on my resume. All right, well, let's level set a little bit on microservices. Now, for better or worse, a lot of people think if I'm going to the cloud, I have to do microservices. And so folks are finally figuring out why they bought Eric's book so many years ago, and they're like, domain-driven design, I get it now. Now I'm looking for bounded context, and I'm going to define a ubiquitous language, and we're going to come up with this mythical two-pizza team concept. We skipped a step. So to paraphrase my favorite fictional chaos mathematician, you were so preoccupied with whether you could, you didn't stop to think if you should. And that has unsurprisingly led to some less than wonderful outcomes. There's a pretty good chance your call structure may mimic this one, right? There's a reason we call these Death Star architectures. No one does that. I shouldn't say no one. I don't think most people do this intentionally. At least I hope we're not doing this intentionally. Now, there are a lot of good reasons to adopt microservices. That's that second report I mentioned. That's where I get into some of the principles that we use. But there are no free lunches here, friends. Everything in our universe is trade-offs. That's software in a nutshell. One of those things that I learned shortly after I got out of school, when you're in school, everything is like, oh, this is an A and this is a B, and you kind of know what that means. And then you get into the real world, and you're like, how do I get an A on this project? And you're like, you can't. That doesn't exist. There is no best architecture. There is no best design. There's least worst. That's pretty much what we're doing. But we have to understand the cost of this added complexity. And we have to ask ourselves very bluntly, does our application actually benefit from that or not? Have I just added accidental complexity to this environment? What we do is hard enough, friends. The domains we work in are complicated enough. We don't need to make it harder. You know, you've probably seen that person at the gym who's so strong they need to like strap weights to themselves when they're on the treadmill or they're doing pull-ups or something, and it's like, yeah, show off. You know, we don't need to do that in our environments, right? We don't get extra credit for that. Now, I would argue microservices are ultimately a reaction to the monolith and some of its drawbacks, as well as these heavyweight SOA things we used to do, as well as what the cloud gives us. Cloud has some super interesting capabilities. Now, monoliths, not a lot of fun. I think most of us would agree. Productivity, not exactly out of this world. It's really hard to load these massive code bases into our brain. It takes a long time to get up to speed on these code bases. You know, I worked on one application where the expectation was it was about a year before you were truly comfortable in the code. About a year. Not great from either side of the employment contract there, friends. You know, I've thought, like, why did we do quarterly releases for so long? Part of it, I think, is just the reality of, hey, you make a small change, you got to build and deploy everything, so I might as well wait until I have enough changes to, justify going through the pain of a build and a deploy. I couldn't scale just the parts that needed. I had to scale the whole darn thing, which meant we had this wonderful sort of single-digit server utilization, which is not fantastic for the folks who are paying the bills. These things are hard to evolve. They're an example of the second law of thermodynamics, which I love to refer to as the teenager's bedroom problem. I am the proud owner of a teenager, and at some point over the last couple of years, I was taking something from his room or putting something in his room, had a really hard time figuring out where the floor was, and I suggested to my wife, now might be an excellent opportunity for Everett to clean his room, to which she replied, which hill do you want to die on today? And I recognized not that one. Now, I wish Everett's room was more organized. I wish my desk was more organized. But you know what? The universe wants to be disordered. That is the natural energy state. Sadly for us, software is not immune from any of that. Every one of you has started on a new project and uttered some variant of, this time we're going to do it right. And 6 months later or 6 weeks later, you're like, oh no, what happened? We had this glorious opportunity and we squandered it. Actually, we didn't. It's just the nature of the universe. Modularity tends to break down. It's harder and harder to add new things. And I feel like that's ultimately what's given birth to this new architectural style. We just kind of keep reinventing the same thing and calling it something new and refining it. Thus was born the microservice. Now, we could probably spend the rest of our time together just arguing about the definition of a microservice. What do you think a microservice is? This is a very much a you'll know it when you see it kind of problem. Or as my old boss loves to say, who wants to argue about the definition of made-up words with me? That's our whole universe, is a bunch of made-up stuff, and we argue about what that means. Now, I'm partial to anything that reminds us they're supposed to be small. So I lean towards anything that can be rewritten in 2 weeks or less, because that's an iteration. If I blow an iteration, I can recover from that. If I blow like 3 months, that's harder for me to justify. That's going to be a much more difficult conversation with the project leadership. Now, Sam put this video out a couple years ago talking about, well, how small is small, basically. And he has a really interesting point, which is when you first start down this path, you're not familiar with it, you don't know, you don't have the muscle memory yet, you don't have the techniques, the tools in place, and so your microservice will be much larger than it will be in sort of year 2 as you start doing this. And you get the muscle memory and you have some of these techniques in place. And you will find yourself at some point on this journey putting something into production that's so small that when you first started, you're like, oh, that's trivial. We'd never put something that small into production. I'm like, yeah, of course we do. It's no big deal. I've had some people tell me, oh, it's anything written by a 2-pizza team. I hate that definition for multiple reasons. First of all, how big's the team and how hungry are they? Right? Like, I mean, that's a single this is actually a pizza I made last year. That's basically a 1-person pizza. I don't think we mean a 2, pizza kind of thing. I don't think we need 2 people on the project. It also gives me no guidance for how many services those people can handle. Because, of course, it depends. And that's the other thing I say an awful lot in this industry. A friend of mine actually has a t-shirt that says, it depends on it. And he kind of wears that all the time. Imagine that. If those services are really stable and they're not changing a lot, that group of folks can probably handle 10, 15, 20 of them. If they're changing all the time, that exact same group of developers might only be able to handle 3 or 4 or 5. Of course, Grady tweeted this out and I thought this was pretty spot on. Microservices are just tiny monoliths. He's not wrong. More important to think of this in terms of characteristics. These are suites of small, focused services. They do one thing, they do it really, really well. It's this Linux or Unix-like concept of saying, let's pipe simple things together to get more complicated results. They should be independently deployable. This gets violated from time to time. A friend of mine actually told me he was on this project where they were trying to move towards microservices, and they kind of got stuck in the middle, and they're like, oh no, what do we do now? Do we keep plowing forward, or do we go backwards? And they realized that they had kind of not gotten to the promised land yet when they were like, if we modify any one of these 7 services, we have to redeploy all 7 of them, and we have to do it in the proper order, or else the databases don't initialize correctly. Oops. They should be independently scalable. They can evolve at different rates. Developers love microservices because I can finally justify using that esoteric language, technology, or database that I have been dying to put on my resume. See resume-driven design from earlier. You know, cart before horse here. This is ultimately all built around business capabilities, though, and it is an example of what I refer to as the 0th law of computer science. You look at almost everything we're trying to do in computer science, it boils down to high cohesion, low coupling. This is what we're striving for. Take the Gang of 4 Patterns book, go through every single one of those patterns. A shocking number of them are this at their core. Different levels of abstraction, different parts, but same basic concept. I would make the argument microservices are essentially high cohesion, low coupling applied to services. Now, as much as I'd like to tell you this is the answer to every problem you've ever had, it's not. It's a style, it's an approach, it's a pattern. It is not Mjolnir. It will not allow you to bring lightning down upon your enemies. You're welcome, Siri. I think I talk with my hands. This is something my wife pointed out to me during the pandemic as she was watching me do a presentation to a screen. She's like, you talk with your hands. And I'm like, yes. And apparently that makes Siri want to do things for me. So this has been destroyed, I believe, in the timeline, although I did see the trailer, and it appears that, I guess, Natalie Portman now gets to carry Mjolnir around. I don't understand. I'm very confused. This, I assume, is a multiverse thing or something. I have not seen it yet, so who knows. Now, I know a lot of us have pitched it that way. A lot of us said, you know, this is the magic hammer that will finally solve all your problems. It's just a tool, friends. It's just a tool. That's it. The challenge for us is knowing when to pick up which tool. Right now, I am not a particularly handy person. I am a software person. Hardware is not my thing. So one hammer is perfectly sufficient for me to screw up any project around the house. My wife and I decided to finish our basement a few years ago, and so the folks that came to work on our basement, they did not have one hammer. They have a truck full of hammers. And they know when to pick up which one. You use a framing hammer for framing. You use a sledgehammer for tearing stuff down. You don't want to intermix those two tools. Yet we as developers tend to cling to that, oh cool, I have a sledgehammer, this is the best hammer ever because the first tool I needed was a sledgehammer. Right, it may not be the best tool for today's task. The challenge for us is knowing when to use them wisely. And don't forget, if you're struggling with the monolith, microservices are not actually going to make things easier in many ways. They're actually going to make a lot of stuff harder. I wish I had tweeted this before Stein, but you know, he beat me to it. Large monoliths are unmaintainable. No, they're not. Poorly structured systems are unmaintainable. Doesn't matter what your deployment topology is. He's absolutely correct about that. It's important to understand that we've got sort of 2 axes here, right? We've got modularity, that's one force, and we've got distributability as another force. And so sitting at the axis of being neither distributable nor modular is everyone's favorite pattern, the big ball of mud. Now, I'm kind of amazed at the fact that I've never met a developer who's like, I'm so happy to work on a big ball of mud, and yet this is probably the most common architectural pattern in existence. This seems like the kind of thing we all need to work out. You know, maybe we really need to have like code therapy or something to figure out why we do this to ourselves. And so if we're on a big ball of mud, we see microservices and we go, oh my God, it's modular, it's distributable. This is the answer to so many of the things that have pained me. I would like to take my big ball of mud and turn it into a series of well-factored microservices. That will solve all my problems. Except that's generally not where we get. In fact, we usually end up the worst of all possible worlds, the distributed big ball of mud. And so now we have all the accidental complexity that comes along with a highly distributed system, none of the benefits of modularity. Please do not do this. Been there, done that, got the t-shirt. It's not worth it. All right? We're better off trying to take this big ball of mud and turning it into a modular monolith. Refactor opportunistically, pragmatically, aggressively. Now from there, you can decide using your experience what makes sense to migrate to microservices? Maybe it's all the system, maybe it's part of the system, somewhere between. That's totally up to you. You know, the beauty of this game is a modular monolith tends to be easier to break down into microservices. You'll have a better sense of where those bounded contexts actually are, a better sense where those seams actually are. You will end up usually in a better place than if you try to make the leap straight to microservices. Now, you hear some people talk about right-size services or macro services. You know, to me, this is just trying to find that kind of happy ground. What's the right size for you? It's not a one-size-fits-all solution. What might be too small for one solution in your system might be too large for another part of your system, and that's perfectly natural. Don't get so caught up in some specific number of lines or anything like that. And you have to apply your experience, your expectations, your understanding of how this makes the most sense. All right? Now, I also think it's important to understand that cloud native doesn't mean you have to do microservices. There is a lot of microservice work in cloud native, but that does not mean you have to have microservices in order to be cloud native. You absolutely can have a well-structured cloud native distributed monolith if you wish. So yes, sometimes the right answer is a modular monolith. Don't kick that to the curb just because it doesn't have microservices in the title. I mean, you can just call it like a large microservice if that makes you feel better. All right, it's important to understand we go down this path. All services are equal, but some services are more equal than others. We need to think about our service level objectives as part of this. One of the things we talk a lot about is availability. What is the availability goal of this service? If you are building these kind of applications, I strongly advise you to familiarize yourself with the SRE book from Google. You do not need to read this cover to cover. It is available online. It is available on O'Reilly's platform. I presume you could get a dead tree version if you wanted to. I actually discovered recently that my son prefers to read dead tree books. And this surprises me as what I can only call like a digital native. I mean, he's as old as the iPhone. So to him, a phone is a slab of glass. And it's amazing to me that he just is not interested. I recommended some book to him and he's like, well, is that on the iPad? I'm like, yeah. He's like, oh, I don't like reading on the iPad. And I'm like, you play video games while watching stuff on your phone. I don't understand. What, you can't read on one of these things? I mean, okay, fine. So familiarize yourself with this. You do not need to read it cover to cover. It's just a bunch of essays. Read them as they apply to you or as you find them interesting. But one of the things that I learned out of this that's important is the distinction between SLAs and SLOs. We often confuse our terminology here. All right, this starts with an SLI, a service level indicator. So this is, as you can probably understand, a simple measure of some part of our system. So what's our latency, what's our throughput, what's our error rate, what's our availability? Now, we usually talk about availability in terms of percentage of uptime. Another way of thinking about it is how much downtime can you tolerate? This is typically called nines. But a lot of us have no idea what nines mean other than I want more of them. Please give me more nines. All right, well, what does 2 nines mean? Your system can be down for 7-ish hours a month, almost 15 minutes a day, and good, you're still 2 nines. I would say that's actually pretty darn achievable for the vast majority of us, given current technologies. You go up to 3 nines, all of a sudden we're talking about less than 9 hours a year, 1.4 minutes a day. You're down for 2 minutes, you just violated 3 nines. That's still probably pretty achievable. 4 nines, we're talking about 4.3 minutes a month, 8.66 seconds a day. Fastest human being on earth cannot run the 100-meter dash in that amount of time. So if Usain Bolt start to finish and your system's been down, sorry, you just violated 4 nines. Hope you didn't have an SLA on that or you owe someone money. Now, God forbid you try to jump up to 5 nines. We're talking about 864 milliseconds a day. If the power fluctuated, you probably just violated 5 nines. Now, of course, the civil engineers, the electrical engineers, they look at us and they laugh when we talk about 5 nines. I wish. Would you get on an airplane that only gave you 5 nines? Probably not. Dan and I were talking about this earlier. My flight down here was delayed because apparently the auxiliary generator wouldn't turn over on the number 2 engine or something, and so we had to pull back in and they had to, literally disconnect it and everything. And in the back of my head, I'm like, probably good not to do like a hot fix on an airplane, right? Like, you guys take your time. You take your time. If you need an extra hour, I'd rather sit here on the tarmac for an hour than, get at 37,000 feet and go, oh man, actually we really needed that other generator, didn't we? Yowza. That's why they have backups to their backups. Now, GKE, last time I looked, I think they've crept this up a little bit, was 99.5. Right, so now they probably could deliver more, but they also understand that when you're giving someone an SLA, this is a contractual agreement, and if they fail, they owe you something. And so they give themselves some wiggle room. All right, so from there we can create a service level objective. So this is a target value or a range of values. So we might say that our availability target is 3 nines. We'd like our average response time to be less than 100 milliseconds. This is challenging because we don't get to choose these in a vacuum. In fact, we're not always the ones who get to choose them. Sometimes our customers have very strong feelings about this. The market may dictate that we provide certain things because that's what our competitors do. And of course, we are subject to anything we depend on. This gets lost on some folks. They somehow think they can exceed the things they depend on. I don't understand where they get that idea. If you are depending on something that's 3 nines, you are not in fact giving someone 4 nines. I am not a mathematician, but that is not how maths works. Sorry. Now, from there, you might create an SLA, a service level agreement. Now we're assigning a consequence. If you miss or meet that SLO or not, we're going to have something behind that. Again, that's a contract, and there's usually some money involved. No consequence, not an SLA, it's an SLO. This is not a technical decision. This is a legal decision. This is a business decision. Lots of people use these terms interchangeably. They are not, and I realize that's a little pedantic, but hey, ubiquitous language. Now, everyone wants all of the nines. Everyone wants hot, hot, right until we have the discussion about how much that's going to cost you. This is the very definition of it. If you have to ask, you can't afford it. So one of my team's superpowers is we will go out of our way to find the best coffee in a given city, especially if we're there for more than a couple of days. And so we had the good fortune of going to Johannesburg a few years back, and so we discovered that the best coffee in Joburg happened to be, for whatever reason, at this very high-end car dealership. And I mean high-end. This was like Lamborghini, Ferrari, restored Corvette, tricked-out Range Rover. No price tags to be seen. Because if you are there to buy a car, you do not care. That's kind of the point. You walk in and say, ooh, I love the red one. Give me that one. And yeah, give me the purple one too. Why not? Right? It's the same thing here. If your business requires these things, they will pay the price to do it. If you are a retailer that cannot be down during the holiday hot shopping period, you will put in whatever effort is required to make sure you can fail over potentially to an entirely different cloud provider if that's what you need to make sure you are servicing your customers at that incredibly critical time of year. Now, it's important to remember that when we put something into production, we're putting an awful lot of trust on it. We trust it to behave, we trust it to perform, we trust it to do its job. Well, how do we know we can trust a service? You might want to actually deploy a checklist. Now, I wish I could sell you, like, again, a fancy tool to do this, but you don't need anything like that. And I know a lot of us look at that and say, but a checklist, that doesn't sound very high-tech. Nate, I want a high-tech solution. If you don't think checklists are interesting, please read this book, and it will change your mind about checklists. This is not a new book. It's been around for a while. I suspect it will change your thoughts. Think about people who use checklists. Pilots and surgeons. There's a reason why air travel is so safe. They have a list they go through before every single flight, after every single flight. The mechanics go through their whole list of things. Part of what took so long on my flight out here is they had a process, a procedure. And again, I am very happy they went through it because every item on that checklist is there for a good reason. It's hard-earned. Someone probably was hurt or even lost their life, and that's why that item exists. Same thing with doctors.
Written in blood.
Yes, written in blood. So I had my hip replaced a few years ago, and there's two really interesting things that happened to me during that experience. First and foremost, every single person I encountered asked me what my birthday was. Now, I assumed that meant they were going to send me a present or a card. Nothing. And then the other thing, of course, they asked me was, what are we doing? Your doctor literally signs your joint. I thought that was like a myth kind of thing, like LOL, yeah, they sign. No, they literally sign the joint. And in the pre-op, if the nurse can't find that, they page your surgeon, and they have to come back and sign it again. Every single individual I met that morning was asking me, what are we doing? And I totally understand why. You don't want any confusion here. You don't want to wake up in recovery and have your doctor say, well, good news, bad news. Surgery went really well. Turns out we did the wrong hip. Don't worry, we'll charge you full price for the right one. It's fine. So there's a reason to apply these kinds of techniques. Anything on your checklist should be quantifiable and measurable. It can't just be fast. What do we mean by fast? Have any of you ever done a rewrite and had the experience of what are the requirements for the new system, and it's usually something like it should work just like the old system, only better. And you're like, better? What does that mean? Great, I can totally do that. I'll get right on that for you. So we need these things to be stable, reliable, scalable, fault tolerant, performant. Do we have monitoring in place? Do we have some documentation? And I understand for a lot of developers, they've just broken out in hives. And they're looking at me going, Nate, I don't have time for all this. I need to move fast and break things. Or my all-time personal favorite, we're capital A agile. I'm like, that's awesome. What happens to your velocity when you have an outage? And have you ever noticed when there's an outage, people you didn't even know worked for your company like appear out of nowhere and it's like, I didn't even know we had a VP of whatever. And they're like, when's it going to be fixed? When's it going to be available? You know, and that only ratchets up the more that outage costs you. Like we had one system that outages were 7 digits an hour. And so anytime that system even like fluctuated, like people just came out of the woodwork and like, I didn't even know you were here. That's scary. And I don't know where they go when the outage is over. It's like they vanish back into the ether. Now, this is one of those things that we need to meet in the middle. We need to understand why this is important. Senior management needs to understand that's why this is important. We're trying to make sure that our services, again, are stable and reliable, and we can do this in a repeatable way. Now, part of the whole point of these distributed architectures is the fact that our services evolve all the time. That's kind of the whole purpose here. We can move more quickly. We can finally embrace that always be releasing mindset. Now, the downside of this is it's like that spinning plates talent where one plate wobbles and the whole thing comes shattering down around you. So how do we make sure our services are stable and reliable? We need a consistent development process. We need to make sure that everything goes through the same gauntlet. Every time there's new code, it goes through new tests, existing tests. We get a couple eyeballs on everything. Maybe we do that through pair programming. Maybe we do that through code reviews. We've got an automated build system. We take advantage of pipelines. We separate this concept of deployment from release. Those are different ideas. We can deploy code anytime. That doesn't mean we have to release it to our customers, assuming we have good feature toggles in place. Got to have good testing, and that runs the gamut. I have had knockdown, drag-out arguments with people about unit testing versus integration testing. You know what? It doesn't matter. We need all of it. You need to figure out what the knobs are for your application, how much of each of these you need, but we need all of it. And this has all got to run inside our pipeline. There has to be a standardized process here. And this can run all sorts of different strategies, you know, whether that's staging, canary, blue, green. There's a lot of interesting ways of doing this. Now, I'm old enough to remember when our only choice for deployment was nuke and pave. You took the new and you overlaid the old and you crossed your fingers and said YOLO and I hope it all works out. Except what happened essentially every time we went to production in this instance? Oh no, there's a break, there's a bug, we have an all weekend conference call. You know, this was the beauty. The system will be down for maintenance from 6 p.m. on Friday until 6 a.m. on Monday. And you're like, great, I didn't have any other plans for this weekend anyway. Fantastic. You know, that was a good era of software. Now, I thought this was in our rearview mirror until my dear friend and colleague Layla tweeted this out last summer. HM.com is temporarily closed. I'm like, .com, how can you be down? There is zero friction here. I'm not going to wait for you to open. I will just point my browser at your competitor and buy it from them. And so my response to Layla was, certain deployment strategies aren't evenly distributed in the wild yet. I would love to know what they were doing that they had to be down for, you know, the weekend, basically. That just struck me as amazing. Because our customers' expectations have changed here. Beginning of my career, it was very typical to say the system will be available 6 to 6, Monday through Friday, and that was good enough for everybody. Of course, that didn't work for one of my systems because I had customers in the UK, which meant 6 to 6 meant noon. That didn't fly for them. And I went back to my infrastructure people and said, but I have people in the UK. Can we get the system up earlier? And they just laughed at me. No, that's our SLA. And I, of course, as just a developer, had no ability to influence that in any meaningful way. Today, of course, if you are down, your competitor isn't, and your customer will happily become your competitor's customers. Now, that has evolved into the recreate pattern. So we're going to spin down the current version, spin up the new version. This has the advantage of being simple, but it also means we potentially have long downtimes, which is less than ideal. That gave way to sort of a rolling update approach, which says we'll do some subset of instances. We'll do those once, some number at a time, which means we can always serve traffic, but you better have your routing correct, otherwise somebody may inadvertently get two different versions of the system. That's not awesome. Also a little harder to roll backwards. So best be backwards compatible and make sure you're familiar with sticky affinity and session management. That evolved towards blue-green deploys. So this is something that Martin's talked about. This ultimately came out of the continuous delivery book. And the idea here is you have two identical environments. One is currently serving production traffic, call it blue if you will. You're doing all your active pre-prod kind of testing, whatever you call that, staging, maint, whatever, on green. If everybody has said this is good, awesome, you update the routing table, now production points at green, and blue just sits there. If after some period of time we're all happy, life is good, awesome, we're fine, we found a mistake, no problem, update the routing table, point back to green. That's all we have to do. Just move things back and forth. Once everything's happy, we just ping pong. Blue has now become staging, green is production. One of the interesting benefits of this is you are essentially testing disaster recovery every single time you deploy, and that turns out to be a really good idea. Periodically you hear some horror story where some company's like, well, turns out we haven't been backing up the database for the last N number of months. Oops. Now, of course, data is one of the challenges in all of these systems. So we do have to kind of think about, is there a way to separate schema changes from application changes? But this does give us zero downtime, and it's very easy to roll back because you just, again, switch your routing table. This massively reduces our risk. This is one of those things about quarterly releases that blew my mind. Such a risky way of doing things. It is a little expensive because I'm essentially running two versions of prod at all times. Still have to think about backwards compatibility. I have to think about how I drain transactions off of those old versions. Now, there is another variant called red-black. I would argue it's the same thing with different colors. Maybe it's just a particular company's branding. We can, again, debate that till the proverbial cows come home. Some have argued that, well, blue-green potentially can have both versions serving traffic, whereas red-black, only one version can serve traffic. So fine, if we want to call red-black a specialization of blue-green, I'm not going to argue about that. You know, again, who wants to debate the meaning of made-up words with me? We can certainly do that. I think it's same concept, different name. Another specialization on this is a canary release. So one of the things we can do is everything looks good in this pre-production environment. We can actually take it to production and give real traffic to some percentage of our users. So this is the canary in the coal mine. So instead of opening the floodgates and 100% of people are getting the new thing, some percentage, 5, 10, 20, whatever makes sense to you, that can ratchet up over time if you want to, giving you more confidence. Now understand, a canary is serving real production traffic. These are real end users. If there's a problem, awesome, roll back. Now, how long should you live in your canary? Hours, days, weeks, I don't know. I learned a long time ago there's 3 answers to every question in computer science. There's 42. That's the geek check to see who's well read. Look to somebody who laughed if you're not sure what I just said. My favorite pattern as an architect is another layer of indirection. But the answer that I have to give so often, I told my grad students this, first day of class last fall, I said the answer to every question is, it depends, and my cohort caught on to that quickly. Anytime I'd ask anything, they just reflexively say it depends, and I'm like, dang it, I shouldn't have said that in the first day. But it's the truth. It's the truth. You have to ask yourself, how critical is this change? How impactful is this change? That's going to guide a lot of your decisions here. If you're changing your fundamental pricing algorithm, and if we screwed this up, that's going to cost us millions of dollars, you might put a little more rigor around that, yeah? Just a little. If it's a CSS change, you might be a little more glib with that, maybe. So this does allow us to test in production without impacting everybody. Does give us zero downtime. It is easier to roll back, but you better have observability in place to make sure you can tell what version are people getting. Now this can also be a little time consuming as well. How long, again, do you want to last in Canary? It's up to you. And you better make sure you are backwards compatible, and let's not forget sticky affinity and session management. Another specialization on this theme is A/B testing. This is actually extremely common. It's a great way of getting some real world data. We have had countless debates in the project room over, does this change add customers or add sales or whatever things we care about? We don't really know until we try it. And it's actually a lot better if we can get real data here. So put a couple of versions into production and do some experiments. See what happens. instead of guessing. So some number of people are going to get the experiment, and now you can actually do some compare and contrast. Again, sure hope you've got your observability story straight. And yes, some people will notice that they're not getting the same version as someone else, and sometimes that makes them very unhappy. Amazon, bazillion years ago, got in a little bit of trouble because they were doing A/B testing on prices. And that turns out to have been a mistake. Target actually got in a little bit of hot water there too, not strictly speaking an A/B test, but they would change the price essentially based on your intent. So if you were at home scrolling through their site or their app and you're like, oh, this TV looks kind of cool, and you're looking at the TV, you'd see one price. If you were in their parking lot of a Target store doing the exact same thing, the price was $100 more because they knew you had intent now. It's always interesting how that happens, isn't it? Now, you can always combine this together. You can do a rolling blue-green. You can do canary blue-green, whatever makes sense for you. Of course, the only answer I can give you to what approach is right for you is it depends. You tell me, friends. You should do what's right for you, your situation. Different apps have different needs. Different services have different needs. Whatever you do, you better automate the heck out of it. Now, if you are having a hard time convincing people in your management structure or even in your development team that, we don't need to worry about all these deployments, this isn't that big of a deal, you should casually mention the night capital glitch. This is one of the only times that you are going to see in an SEC filing a whole bunch of techie talk. This is one of the few times that we can actually look at this and go, hey, I know what went on here. All right, so zombie software caused an automated trading algorithm to go nuts. Now, they made a couple mistakes here. The first one was they repurposed an old flag. Never, ever repurpose an old flag. Then they did a rolling deployment, except they missed one of the servers. 7 servers had the new version, 1 didn't. It turns out this is actually a huge problem. They managed to lose $500 million and 75% of their market cap before they were bought out by a competitor later that week. So the moral of the story here is you best be reliable and repeatable when it comes to releases. You should never, ever rely on a human being doing something perfectly without fail. We are not capable of that. We are human beings. Automate everything and then automate some more. This will help you actually get a good night's sleep, which is pretty darn important. This is yet another example, of my opinion, of the shift left that we've seen in our industry for the last 25 years, to be honest with you. It started with testing. We need testing to be better. I shouldn't say better. We need to make sure the code that gets to our testers isn't just a steaming pile of it doesn't even work. We need to make sure that our testers can work on the things that testers are really good at, trying some of the more nefarious things that human beings will do to your application. And so we keep kind of shifting things left. And why is that? Because it's a heck of a lot easier to fix that problem earlier in the process. Period, full stop. Of course, the best time to fix it is before you even design it. We have so many problems of misconception in this industry, it's ridiculous. My wife's a business analyst, and it's amazing to me how often I hear some variant of, well, the developers have to start working because the developers are ready. We don't have the requirements yet. It doesn't matter, they need to start working. And what do? They just start banging out code that all gets thrown away. Well, ideally gets thrown away. In the worst case, they're like, jam it in, make it work. My favorite example of this is a buddy of mine was on a project, and they had these concepts of client and customer, and they assumed, there's a dangerous word, that they were interchangeable. And they got about 4 iterations in, and their product owner said, well, that'll work for a client, but not a customer. And everyone kind of like, record scratch sound, like, wait, what do you mean? Client and customer were 2 distinct concepts that were similar, but different in important and interesting ways, and they had to do a bunch of rework. Much easier to find that early on, say, I'm sorry, are client and customer the same thing, than get several weeks in and realize, oh no, they're not. Another way of thinking about this is once you've taken the cake out of the oven, it's really hard to decide, oh, I didn't want a chocolate cake, I really wanted a marble cake. Well, too late, it's already baked. Now, my opinion here, friends, is this is table stakes now. This was a competitive advantage at one point. It's not anymore. Now, my favorite example of what this can look like in the real world is when GitHub replaced Merge. Do any of you remember when GitHub went down for 2 weeks so they could replace Merge? Of course not. They didn't go down. They replaced Merge while we were merging code. All right, ponder that for a second. Now, we can have a discussion about what are the top 5 features of the source code management tool. Merge is in there somewhere. This wasn't like they updated the UI. I mean, this is merge. Now, to be very clear, they put a lot of effort into this. But this is the example of, oh, sure, no problem. The mechanic's out on the wing right now fixing the engine while we're cruising at 37,000 feet. Don't worry, they have safety harnesses. Now, they were kind enough to write about it. And again, a tremendous amount of engineering effort went into this. This was not something they just sort of like, roll the dice, YOLO, let's see what happens. I mean, they put some thought into it. I bring this up simply because I've been on plenty of projects where we agonize over really simple changes. It's like, well, if other people are capable of fundamentally changing their system while people are using the system, we may need to rethink our approach here. The way we've done it for a long time may not work. The most dangerous phrase I hear in companies is, that's how we've always done it. That needs to just like disappear from your lexicon. That does not mean it's the right way to do it. That does not mean we should continue to do it that way. Now, in a perfect world, this means we have already found most of our issues. Our customers should run into almost nothing. We have found it in one of these steps. It's also important that our deployment pipeline is the path to production, period, full stop. Very dangerous to just log in and, oh, just put this fix into production. It's fine. Don't worry about it. Just SSH into that server. That way lies madness. This will almost by definition inject new bugs into the process. You also cannot reproduce production now. We have no idea what it is. Been there, done that, got the t-shirt, don't do it. If you have a problem, roll back. We also, of course, need to understand all of our dependencies, like, I don't know, log4j, for instance. Oops. How many, I don't know, I'm sure some of you saw this tweet, but it reappeared, I guess, after the log4j issue, and it was all these like building blocks of a system, and then there's like this little toothpick over in the corner, that system maintained by one person in Omaha. And your whole system depends on this one little toothpick over here. Yeah, it's kind of amazing. I'm actually kind of just stunned software works as often as it does. I think we should like be patting ourselves on the back that it doesn't fall over more often when you consider how many moving parts are in there, how many of these dependencies. It's like, I mean, there's all this stuff working together. Because it's never just one thing. If it was just one thing, that'd be easy. If you ever look at any of the root cause analysis on any of these outages, it's this and this and this and this and this happened in this order at this time. Any one of those things doesn't happen and this outage never appears. That's part of the maddening aspect of the fact that software is eating the world. I mean, I guess that's good for us, but we need to expect that things are going to fail. We need to remember that these dependency graphs get a little crazy. Again, I love going back to this. We've all been there. We've all done that. I assume this is why Death Stars keep blowing up in every other movie. They use that same architecture. So what do we do? How do we mitigate this inevitable failure? Because we know things are going to fail. Maybe we cache. We have some cached results. Maybe we call an alternative service. We've got a backup thing in place. Depends entirely on the criticality. If you are a retailer, you need to accept money from someone for product anytime, any day. That doesn't mean it immediately ships to the warehouse. So different parts of the system have different availability needs here. I spent a lot of my career in insurance, and I assure you, insureds will file a claim in the middle of the night. They do not ever want to see your system down for maintenance. Those systems are up 24 hours a day, 7 days a week, 365 days a year, period, full stop. That does not imply we have dispatched a claims adjuster 5 seconds after you hit submit. Maybe it sits on a queue and gets picked up later, who knows? We need to make sure our services have health checks. I live in the Java ecosystem. I love Spring Boot Actuator. It gives me a ton of stuff right off the top, but whatever system you're working on, you've got to have health checks in place. If it turns out we're unhealthy, well, don't route traffic here. That should be pretty obvious. You need to have circuit breakers in your code base. So this comes from our friend of mine, Michael Nygaard, circuit breaker pattern. Basic idea here is it works just like the circuit breaker in your house. Now, it's a little counterintuitive for those of us that are not electrical engineers. Basic idea is if everything is good, the circuit is closed and traffic flows through, just like the circuit in your house. Then, uh-oh, there's a problem. We open the circuit. Now we don't let calls through. Let's not burn down the house. Same basic concept. It exists to defend the neighborhood. Your services will not live forever. You need to have a plan for decommissioning it. This is another one of those cultural issues. So much of what we're running into software is not a technical problem. It's a cultural problem. It's a people problem. We forget about that at our own peril, by the way. Software projects are people projects. I know a lot of us get into this industry because, oh, computers, they're not as messy as humans, except you realize every project you're on involves humans, okay? Just comes with the paycheck, I was told often. So we need to plan on them being decommissioned, so there has to be some kind of deprecation period. So we need to have that communicated out. Yes, we're going to shut this service down in 2 months, 6 weeks, whatever it is. Most of the time, you're going to keep that service around past that and monitor it. Give people a little bit of cushion, because there's always that one person who wasn't listening. The worst thing you can do in your organization is just let a service go feral. That way lies madness. So let's talk a little more about fault tolerance. You cannot prevent bad things from happening. Bad things are going to happen. You can build resiliency into your system. Another way of saying this is hope for the best, prepare for the worst. Now, I'm convinced that Margaret Hamilton, pictured here, is the very first SRE ever. Of course, the title didn't exist back then. She worked on the Apollo software. And so one day, depending on which variant of the story you read, she was in the lab doing a simulation of a lunar landing, inadvertently pressed a pre-launch button that wiped out the navigation data. Now, bear in mind that in this room right now, we have orders of magnitude more computing power than NASA had to put human beings on Earth. You know, I'm fairly confident that like our phones were more powerful than the lunar landing computers. Right? And yet somehow we managed to put somebody on a distant block of dirt in the universe. So she did what any good engineer would do. She went to her superiors and said, we need to prevent this. We need to put code in to make sure this doesn't happen, because, you know, recalculating 250,000 miles away from Earth is not a good thing. Interestingly enough, her superiors disagreed with her, and they said, that's crazy. That will never happen. And besides, the astronauts are perfect. They're highly trained. We'll simply tell them, don't press the button. You know what happens when you tell somebody not to press the button. So my family and I went to an AJR concert in June, and one of the merch things they had was a red button that says, do not press. And so I bought one of those, sitting on my desk right next to my bless your heart button that my dear friend Glenn sent me. And it's really tempting. Like, it sits there, I'm like, damn right I'm going to press that button. So it happened. Imagine that. Shocking. Now, luckily for those astronauts, she did get the documentation updated, and so they were able to recover from it. It wasn't the catastrophe that it could have been. To paraphrase my favorite fictional chaos mathematician once again, failures find a way, despite all of our best intentions. So look through your code base. Where are the single points of failure? If you're unsure where those might be, draw the architecture up on the proverbial whiteboard, point at something shiny, and say, what happens if this fails? I get to do this a lot, and one of the things I hear a lot is, it can't fail. Sometimes I laugh out loud, sometimes I'm more professional and I bite my tongue before I do that. You know what? It will. We need to think through how things might fail, and I understand how hard that is. We are an optimistic species, despite all the evidence that we've accumulated in software for our careers. We are really good at happy path. We need to think about the road less traveled. Now human beings adapt to things naturally. We don't even think twice about it. If you drove here today, you didn't just like point your car in the general direction of this building and hit the accelerator and close your eyes and hope for the best. You were making constant adjustments to speed, you're changing lanes, maybe you're like, oh, there's construction, I'm gonna take a totally different route. You adapt naturally and don't give it a second thought. Software cannot do that. It only does what we tell it to do. Computers are really smart at being stupid. And I've had a lot of those debates with customers who are like, oh, it's like, if you don't tell me what you want the system to do in this scenario, I will make it up. And you may not like what solution I come up with, because I'm going to do whatever's easiest for me. So we need to think through those scenarios. We need to test for those scenarios. Now, to be honest with you, the only way we really know about some of this is by unleashing some chaos on our system. You need to poke and prod and try things that are not going to come to your mind naturally. I would love to have been a fly on the wall when this stuff was first brought up in Netflix. I mean, someone like us was sitting in a room and said, okay, here's my plan, hear me out. Some point in the future, I'm not going to tell you when, I'm going to go down to the server room and just randomly yank out some cables and see what happens. Everybody good with that? Pretty confident that was met with a cold response and perhaps like, please don't ever come to this meeting again. But this is why ultimately Netflix is as rock solid as it is today. Talking about expectations changing, I am old enough to remember when I thought it was mind-blowing that I could navigate to a web page and an image appeared. And now we get grumpy when, oh, it's a little buffery. My HD TV isn't streaming. It's like, it's amazing how fast we flip that switch. And it's even worse when you've got like a youngling. My son and I were watching some show, and he stared at the screen. He's like, what's wrong with the TV? I said, what do you mean? He said, why are there black bars on both sides of the TV? And I went, oh, yeah, this was done in 4:3 format, not the 16:9. She's like, oh, it's so weird. I'm like, sorry. Like, we didn't have HD when I was your age. I guess, is that like the color of today? Like, oh, we had black and white TV. Like, I don't know. Who knows? I'm sure there'll be something in the future, right? We'll be like, the kids these days, beaming it straight into their neural cortex or something. So we need to try these things. We need to push our services over and over and over again. We have to intentionally break things. We need to add some latency. Shut down an AZ. See what happens. I still think one of the most gutsiest things I've ever seen in a keynote, this was at Spring One Austin. I don't know if you were there, Dan. During the keynote, one of our clients literally shut down not just a zone, they shut down a provider. They showed all the traffic flowing from one cloud provider to a completely different cloud provider, and they're actively saying, please bang on our site while we do this. I'm like, I mean, still the gutsiest thing I've ever seen. And it worked. Credit to their engineers, amazing engineers. It's a lot of work to make that happen. So we need to do these things. Just make sure it's not ad hoc, and make sure that you tell people you're doing it so they're not like freaking out at what just happened. Because yeah, this can go rogue. Some stuff's going to fall through the cracks. We need to detect when that happens and then add that into our testing suite. Those failures could be internal, those failures could be external. Do we have good exception handling in place? You're going to write bugs, you're a human being, that's perfectly fine. That doesn't make you bad. Just make sure you're testing thoroughly. Something you depend on will fail. Some downstream thing will fail. How do you recover from that? Again, this is all about resiliency. So you have to make your services fail again and again and again. We need to think about performance testing. Like, where do we run our performance tests? Do we do it in some performance region? It's not a bad place to start, although a lot of people today are running that in production, which is a little scary at first, until you realize that, oh wait, my customers are testing in production right now. Sure hope it's working for them. Just make sure that these are synthetic transactions, or you end up with a bunch of washing machines at corporate headquarters. Right? So we got to be a little careful if we're going to do this in prod. Right? So make sure those are marked appropriately, and of course make sure everyone knows you're doing this so that they're not freaking out that, oh my God, we just saw a 10x increase. For most of my career, performance testing was that thing we did once about 6 weeks before I went to production, and then we took the results and put it in a drawer because there's nothing we can do about it now. We're going to production on Tuesday. And that's great until you realize, oh wait, when did that performance problem happen? One of the first things I had to do when I was a newly minted architect was go solve a performance problem on a VB6 app. And so of course, I've never written a line of VB6 in anger in my entire life. I have no idea what this system does. It's been around far longer than I have at this organization. So I asked a couple questions, one of which is, do we have a performance region? To which you say, no. And I say, interesting, can we spin one up? No. And I'm like, wait, what? The person who knows how to install it doesn't work here anymore. I'm like, that seems like a problem. And then of course, the other thing is then I asked, well, how long has this problem been going on? And they said, we're not sure, sometime in the last 3 years. Great, so it could have been any one of how many thousands of changes. That's going to make this so much easier for us to unwind. Good times. I would much rather see that be an automated thing that's run on some regular cadence, whatever cadence makes sense for you. But hopefully we can find, again, those problems before they start to affect our customers in unintended ways. Just don't do that during whatever your peak traffic hours are. The whole goal with all these techniques is reducing impact on our customers. We want to find this before they do. And if we have a problem, roll back. If we have a problem, fail over. Automate as much of this as humanly possible, and then automate some more. Again, all services are equal. Some services are more equal than others. What happens if this one goes down? We need to be able to map that into our brains. Some services, if they're down, that is a catastrophic all hands on deck experience. Others, we don't have to rush. We need to think about these incidents in terms of severity and scope. So what is the impact to the business? And how much of the business is impacted. It's an important part of this equation, to say the least. All right. skip over that. I have to talk. All right, let me talk about these real quick. Production readiness reviews. Big believer in this technique. This is not a one and done kind of thing. We should be reviewing our services on a regular basis. This is not a high ceremony thing. I've been involved in too many things that have like review board in the title. Those don't work. Get the right folks together, devs, architects, SREs, whomever. Do we all understand what this system does? You know what the answer to this is going to be? Nope. Do we all understand the requirements? Nope. This will clear up some misconceptions. Walk through the app. There's going to be some interesting bottlenecks. Oh wait, that thing we rely on doesn't have the right SLA for us. You're going to find some interesting failure case that, by the way, almost always involves time. Years ago, I worked on this application that we wrote for another part of our company. We handed it over to them, and I don't know, a month or two later, my director comes over and says, hey, you know, you worked on that Wombat thing, right? I'm like, yep. He said, they had a build break this morning. Can you help them? I'm like, of course, but they should just look at their last commit. That's probably what broke the build. He said, well, that's the thing. They haven't actually touched the code in a couple of days. They don't know why it broke. So I went and looked at their build and saw there was a failing test. I went and looked at the test, and I realized, oh, this test is going to fail every 7 years. I wrote it, it's my fault. I don't honestly know how I fixed it. I may literally have just put a note in there that says, yes, this will fail every 7 years, sorry. I don't know. But there's a lot of that in software. Oh, month end also corresponds with a bank holiday, which also corresponds with a, you're like, oh, okay, what does that mean? This is probably going to result in some pictures. This is probably going to result in some new items on your backlog. I challenge you to do an audit of one of your services. Go back to that checklist we talked about earlier. Does this actually meet all the requirements? Pretty much a guarantee this is going to result in a few new things for your backlog, which you now have to prioritize along with everything else you have on your backlog. We need to think that through. When, can, and should we fix this? We do have to think about prioritization. Now, I know a lot of what I've talked about here is manual, but you need to automate as much as humanly possible. Automation is your friend here. Now, again, I am old enough to remember when builds were a Rube Goldberg machine. It was all manual. Right click, take that deployment artifact and put it over into this magic drive location, and then some cron job picks up, and there's, don't tell anybody, but there's hard-coded credentials in clear text, but nobody knows where they are except everybody. And this worked for some definition of work, and it's okay because we don't do it very often. Now, I will go out of my way to seek out artisanal coffee. It is absolutely worth the effort, at least to me. We cannot afford bespoke builds today. Human beings are incapable of repeating. If you don't agree with me, take up golf as a hobby and get back to me. Whether you like it or not, we all have bad days. We all get bored, we skip a step, we fat finger a command. I mean, how often have we seen that instance where, oh, something's down, why? Oh, because some engineer typed in this instead of that. I'm sure some of you got this email from HBO. Sorry, integration test email, this only for integration testing. I am so glad this came out because this was a good reminder to all of us that we all make these kinds of mistakes. Moral of the story, friends, is we have to have automation in place. Computers don't do that. A long time ago, I learned in computer science there's only 3 numbers. There's something you do 0 times, there's something you do once, and then there's n. If you do it twice, you're going to do it 1 billion times. To sum that up, anything you do more than once, you should automate away. Please. It'll help you get a good night's sleep. Well, friends, that's all the time I have. I do appreciate your attention. I hope you enjoy the rest of the show, and thank you all for hanging out. I appreciate it. Cheers.